Alright everybody, welcome back. Let's talk about our second lesson in this playlist. We'll talk about arithmetic series. So remember last time we started talking about an arithmetic sequence, and we said that an arithmetic sequence is such that each of the terms are different by a common difference. So there is a certain number that we could add to keep getting each consecutive number in that sequence. Now a series is related to that in such a way that the series means that we're going to take the sum of all the terms in that sequence, whether it's the 6 terms, 100 terms, a million terms. We could add up all those terms, and that's what the series would be. We're going to take the sum. Now an arithmetic series is, well, if I take the sum of the terms in an arithmetic sequence. So I have to know if it's a sequence first, specifically an arithmetic sequence, before I can find out what the sum is of a certain number of terms. So here is an example of a sequence, right? 5, 8, 11, 14, that's a sequence of 4 numbers. Their common difference seems to be 3. Every consecutive term is obtained by adding 3 to the previous one. Now the series is by taking those 4 terms and adding them up, literally the sum of them. So we can take the sum of those 4 terms. Now let's think about the formula to this. Well, if I take an arithmetic sequence and I add up the terms, well, here's T1 of that sequence. I'll highlight it in green. There's T1. T2, which I will highlight in red. So if you remember our first lesson in this playlist, well, we took our first term, we added in our common difference. That would have given us T2, and I'll label it underneath. This is our term 2, which means that this is term 3. If I add to my first term 2 common differences. And I could keep on going an infinite number of times for however many terms I need to have in that sequence. Now the sum here, the sum of that arithmetic series is me literally taking all of those terms and adding them together, which is why you're going to see plus signs in between all of them. Now, if you take that series and reverse the term order, so if you literally take those numbers and flip them around, instead of starting with T1, we'll just start with the last term instead. So T1 is going to be the last one. We'll reverse the order of all of those, and this is what you would obtain underneath. So the top row here is our sequence, us adding up all the terms. That'll get us our series. Now the second row is us just reversing them, right? It's just flipped. So our Tn is last. There's our general nth term of this series. T1 is last. There's our first term. Right? So we just flip them. But if we add them together, something interesting happens. So I'm just going to put a plus sign here, and we'll add them up. So Sn plus Sn, the series, the sum of the first n terms, if I add that to the other one, I'm going to get 2 Sn, 2 times the sum of the first n terms. But here's what happens inside, and I'm going to use some boxes to do this. If I take T1 and I add it to Tn, well, they're not like terms because they're different. So this will end up being T1 plus Tn. But if you look at what we said was our second term here, the things that are in the brackets, well, your common differences are going to cancel. One's a positive, one's a negative. They have the same numerical value. One positive, one negative means they cancel out. They make a 0 pair. But look at what you're left with. T1 plus Tn. It's the exact same thing. And you'll see this pattern happen the entire way down, no matter how many terms you have to deal with, all the way to the end. Which means that if you do this for your sequence, which may have n number of terms, well, you're always going to end up with n T1 plus Tn's. That red box will occur n number of times, however many terms you have, which is what you can see down below. So this is what happens when we add them together. We get a bunch of T1s plus Tn's. Now if you isolate this equation for Sn, well, if I simplify it a little bit, like I said, we have n number. So n of these, right? We have n times T1 plus Tn. There's n of them. I don't know how many n is because, well, it could be infinitely many. So if I divide both sides by 2 to simplify and isolate for Sn, which stands for the sum of n number of terms, right, I end up with n times T1 plus Tn divided by 2. And this formula will allow me to calculate the sum of any number of terms I want, provided I know that number of terms I'm looking for, I know the first term, and I know what that last term happens to be, or the term that we want to use to do this. We'll do a couple examples, and maybe that really helps illustrate it for you. Now, we learned a new formula in our last lesson that said, well, hey, if this is an arithmetic sequence, I know that Tn is the same thing as saying the first term plus n minus 1 common differences. So if for some reason I'm not given enough information, well, I can take out Tn in that red box and replace it with what Tn is equal to. So there is another way that I can use, this form to do this. Right, there's another form of this formula. So I'll write it for you in, actually, you know what, it's on the next page. Excuse me. So you can substitute that inside. In 1 second, just got a little tickle here. Okay, so if you substitute that inside, here's the two forms of that formula, which you could see. There's the one on the left that we just came up with together. And if you replace Tn with what it was equal to, so remember that Tn is our first term plus n minus 1 differences, you can replace that, and what you will end up with is this version of that formula on the right. Right? You already have a Tn to start with, so if you take out Tn and put in what it's equal to, you're introducing another T1 into this. So this is really like saying, and I'll put it in purple maybe, the original T1 you had plus T1 plus n minus 1 differences. So T1 plus T1 is the same thing as saying, well, I have two T1s, and then my n minus 1 differences just stays and gets attached and added after. The reason why you see the common difference, it could be at the end or the beginning. Well, multiplication can happen in any order, right? I could reverse them, right? D times n minus 1 is the same thing as n minus 1 times d. It doesn't matter which order you place them. So let's use this to try out, a couple examples and see how this works. So leave our formulas there at the top, just so we can look at them. Determine the sum of the first 6 terms of this series. So I've got a bunch of numbers. It's arithmetic, so I know there's a common difference. So let's just write out some things that we know. That way we know which of the two versions of that formula to use. So our first term, T1, that's 25. Our common difference, I could figure it out, but let's assume that we're going to try to use the shorter formula, where in there you can see we don't even need the common difference. So let's see if we can find everything else. That way I can avoid using the longer one. T1 is 25. Tn, well, I know that in question we're talking about the 6th term, right? So the 6th term is negative 30, which means that n happens to be 6. There's the term that we're going to use to do this, because we're looking for the sum of the first 6 terms. N is going to be 6. So that seems like all the information I need. Here's my formula. The sum of the first n terms is equal to n T1 plus Tn over 2. Plug in everything that you know. So we're looking for the sum of the first 6 terms. So n is 6, T1 is 25, plus Tn, which in our case is going to be T6, the 6th term. So plus negative 30, and then divide by 2. So you can simplify this, and you will find out that you get, let's see, am I looking at the right? Oh yeah. Okay, so the sum of our 6 terms is equal to 6 multiplied by negative 5 when you simplify over 2. So the sum of the first 6 terms is 15. Now it's not terrible, you could have added them together by hand, but what happens if you're looking for the sum of the first 600 terms? That might be a little bit more challenging. This is where this formula becomes nice. Okay, so it is small, you can check it by hand and make sure that it still works, but we get 15. So let's look at the one underneath where it says we've got an arithmetic series, T1 is 3. The common difference is minus 4. Determine the sum of the first 25 terms. So that's what this says. Okay, maybe we'll add that in. So this will tell us we're looking for the sum of the first 25 terms of this sequence. Right? That's what our series is saying. We're looking for the sum of the first 25. So again, it's helpful to list out what you know. So T1's 3. The difference is minus 4. I'm looking for the sum of the first 25, and if I'm looking for the sum of the first 25, I'm going to need the 25th term. Unfortunately, I also don't know what that is. If I try to use this shorter formula for before, in purple, if you look above, well, Tn is really going to be T25. The issue is I don't know T25. So I could find it first and then use it in my formula, or I use the longer formula to do this. So I'm going to go find out what T25 is first. And that means Tn, if this is arithmetic, means I can use T1 plus n minus 1 differences. So let's go find out what T25 is first and then use this in our new series formula. So Tn, that's going to be T25. T1 is 3 plus, well, n is going to be 25, so minus 1. The common difference here, minus 4. So our 25th term has a value of some number, which I don't know at the moment. So let me grab a calculator here. There we go. Oops. Where did my calculator go? There it is. All right, I can do this, I swear. So 3 plus, well, 25 minus 1 is just 24, multiplied by negative 4. So our 25th term, negative 93. Negative 93. Now I know that 25th term, I can use my series formula. So I can find the sum of the first 25. Actually, let's write the generic one. So sum of the first n terms is equal to n, T1 plus Tn times over 2. Oops, let's get that calculator out. There we go. So there's our formula. Let's plug in what we know. I'm looking for the sum of the first 25. So that's equal to n is 25, T1 is 3, plus Tn, so plus our 25th term in this case, which we just calculated as negative 93, divided by 2. So let's plug that part into there now, see what we get. So 3 plus negative 93 should be negative 90. We'll multiply it by 25, then divide it by 2. So if we take the first 25 terms and add them up, we will get negative 1,125. Negative 1125. There is the sum of the first 25 terms to this series. So again, way more efficient than sitting there and adding up 25 terms. Way more efficient. Problem is, I may need to use this in 2 steps. You could have also used this larger formula to do it. I chose not to. Works out the same because essentially you're just plugging all the information you have into one formula, which is the same thing as doing it in 2 steps. So you can try that. Works out to be the same. Okay, so let's take a look at our last example here before we wrap this video up, which says you've got an arithmetic series. The sum of the first 15 terms is 93.75. The difference, common difference between the terms is 0.75, and the 15th term is 11.5. Determine the first 3 terms of the series. Now, in order to do this, in order to determine the first 3 terms, well, I know the difference, right? I don't really want to work backwards from the 15th term to go all the way back to 1. So essentially, we're going to be looking for that first term, right? That's the goal. Find T1. If I know the difference, well, then it's pretty easy to find the first 3 terms. So T1 is what we're looking for. I know that the first 15 terms add up to 93.75. I also know the difference is 0.75, and the 15th term is 11.5. So since I know both the sum of the first 15 and the 15th term, I'm going to use the shorter formula. Usually if you don't know that Tn value, you're going to be looking for the longer one, but since I know both, we can use a shorter one. So n, T1 plus Tn's over 2. Fill in everything you can, and you'll see that T1 is the only thing you don't know here. So Sn, in our case, the sum of the first 15, is 93.75. that's equal to, well, in this case, n is 15, right? I care about the first 15 terms. I know the 15th term. All of the n's that you see in here are the same n. So they're all going to be 15. T1 is what I'm looking for, so leave it as T1. Plus that 15th term value, which is going to be Tn, so 11.5 over 2. Essentially, we're just going to simplify and solve this for T1. So multiply both sides by 2. And I don't know what these numbers work out to be, so let's do 93.75 times 2. Okay, that works out to be 187.5 equal to 15 T1 plus 11.5. Oops, that's not a nice 5. There we are. At this point, I would probably divide by 15. Okay, you get 12.5. Okay, so 12.5 is equal to T1 plus 11.5. Oops, there we go. In order to get T1 isolated and by itself, subtract 11.5 on both sides, and you will find out that 1 is your first term here. Okay, the value of T1 is 1. And if I know that, and I also know the common difference, I can find terms 2 and 3. So if T1 is 1, that must mean that T2, I'm going to write that the other way around, looks weird. T1 is equal to 1. That means that T2, do this in blue, T2 must be 1 plus 0.75, which should be 1.75, which means that term 3 should be 1.75 plus 0.75 for a value of 2.5. So there are your first 3 terms, right? We worked backwards, we found the first term, and then used that common difference to keep going for the other ones. It's a little easier to work from T1 to T3 than all the way back from term 15. You have to do it a lot of times by hand. The issue is what happens if you hit add instead of subtract. Like, there's a lot of times you'd have to do that, a lot of iterations you'd have to run through to get all the way back to 1. So there you go. There is a little bit of stuff on arithmetic series as opposed to arithmetic sequences, looking at the sum of terms rather than the pattern and those individual terms. So I hope that helped. And again, you will find the links to all of these documents, keyed solutions, blank copy, in that description box as well. The next time we see you, we'll talk about geometric sequences and series, the differences between them. Later on, we'll talk about infinite and finite series, so look out for those ones. Until then, enjoy the rest of your day. Take care of yourselves. Bye-bye.